Hello science fans, welcome back to Science Fun with Austin. I'm here with Noah today and we're going to be talking a little bit about oxidation reactions.
Wait, what's an oxidation reaction?
So, glad you asked, Noah. So basically in an oxidation reaction, something like, say this iron nail, reacts with something like the oxygen in the atmosphere. The iron gives up electrons to the oxygen and it forms a compound, iron oxide. So that's the reaction we're going to be looking at today. Alright, so we've set up a few different combinations. I'll point at bowl number 1 here, which is just a nail in plain water. And then bowl number 2, which I'm pointing at now, has boiled water, which has a layer of oil over it to isolate the water from the atmosphere. Jar number 3 over there contains salt water, which should have more ions than the regular water, and our hypothesis is that that one will corrode the fastest. To see if the water matters, jar number 4 that you can see here contains a nail with just dropped in dry salt. And then every good experiment has a control. I'll point at number 5 here, and the one I'm pointing at there is just a nail in plain air. So we have several variables and a control, and we'll see what happens. Alright science fans, it's been 2 weeks, and let's see how our experiment has proceeded. So we've got the nail number 1 here, which was just in plain water. And you can see number 1, a fair bit of the water evaporated. Really, probably we should have kept that topped off to keep it controlled. But you can see right where the head touched the glass and where the nail was in the water, you have a lot of corrosion, kind of like we figured. We've got nail number 2, which was in the oil. This one actually corroded a fair bit more than we thought it would. I think part of the issue, if you look, you can see that the rust mark from the head of the nail is actually well into the oil layer. We probably should have had that a little bit deeper so that the nail was completely in the water instead of the oil. Number 3 did pretty much exactly what we thought it would. This is the salt water, and you can see that the nail is very heavily corroded and there's a lot of rust in the water. So, kind of as you'd expect, brine turns out to be pretty corrosive. Number 4 is the dry salt, and you see that really nothing much happened to the nail in dry salt. Without water, you just can't really get the ion exchange going. And number 4 is pretty much indistinguishable from number 5, which was our dry air control. So our hypothesis that the salt water would be really corrosive turned out to be correct. Turns out we probably have a little bit of an experimental issue with our oil water sample that caused that to corrode more than we expected. But everything else behaved more or less like we thought it would. So thanks for watching, and see you next time, science fans. Alright, so we talked about ordinary reactions between iron and the atmosphere, which normally require water with some dissolved ions to facilitate electron transfer from the iron to the atmospheric oxygen. However, under kind of different circumstances, if the iron is hot enough, it can react with atmospheric oxygen directly. How could we possibly get iron hot enough? Let's see if we can make it work. So we can see that the microwave has heated up the steel wool. But you see that the steel wool keeps burning. It's actually, the iron is actually burning in the atmospheric oxygen because we got it hot enough with the microwave. Oh, looks like we also got our fixture on fire here. Probably need to do something about this here. I forget it.
This is what you call science fun behind the scenes.
Woo! Oh goodness.
Hey, you got to throw this in. We just did some cameos.